Mhm. Yeah.
Initial concentration to the power n minus 1. Here, that's what we had seen. Okay, and the half-life n minus 1 for the first order, it is this expression I was talking about. And for the first order reaction, this is 0, n is 0, n is 1, so power becomes 0, and it doesn't depend how much you take in the beginning, right? Half-life for the first order reaction, it remains same, 0.693 by K. We did a lot of examples about the half-life in the last class. And also I discussed how much amount is left after you cover the time period equal to n times the half-life. So first half-life, the substance get half, the second half-life, okay, it becomes half of the initial concentration. Okay, after one half-life, after two half-life, after three half-lives, right? This is after one half-life, 50% is completed. After two half-life, 75% is completed. And after three half-life, 87.5% is completed. So this is how it so completed, and how much is left. Okay, you can subtract from 100. Is it clear? So this is all what we did. Any doubts on this? Ibrahim, Jaslin, good evening. Am I audible?
Yes, sir. Yes, sir.
Okay, great. So, and today we are going to discuss another method to find the rate law. And what we are going to discuss? We are going to discuss the mechanisms. Okay, so we have seen some mechanisms in organic chemistry also. Got it? So what do you understand by mechanisms?
The method by which a chemical reaction occurs, like which molecule attacks which molecule.
Exactly what is happening within. There is a chemical reaction. Okay, that gives you the total number of moles of reactant and products, right? And but how that bonds are being broken, how which is reacting with whom, what is the sequence, exact sequence of reaction between the given reactants, and what are the species which are formed during the reaction, in the middle of the reaction. Okay, they are known, all that study comes under the heading of mechanism of a chemical reaction. Got it? So mechanism actually, on the basis of mechanism, reactions can be classified into two different categories. What are those two different categories? Can you tell me? Mechanism of chemical reactions. Yeah. So the mechanism, on the basis of mechanism, I can divide the reactions in two different categories, and they are Single step and multi-step. Single step mechanism and multi-step mechanism. Okay. And what is the other name of this single step and multi-step? These are some common words, but in as far as the kinetics is concerned, they are not common. They carry specific meaning. So Ibrahim, what are complex reactions?
The one which have like multiple steps occurring.
Yeah, but by looking at the equation, you can't predict whether it is a single step or multi-step. Got it?
Yeah.
Actually, you need to do some experiment, you need to do something, and that can let you understand that whether it is a single step or a complex step. Got it? So elementary reactions and complex reactions. Got it? Single step reactions are elementary reactions, and for example, two HR gives H2 plus I2. So if it is a single step reaction, elementary reaction, it is necessary for all the reactant molecules mentioned in the equation to undergo collision simultaneously and form a product molecule in just one step. Okay, there are no two steps. Are you getting my point or not?
Yes, yes, yes.
Jesslyn, Marwa, Aisha. Single step means whatever is given, they should collide and form the product. That's it. Got it? Is it clear? So, and complex reaction, it doesn't take place in just one step. Suppose some bonds may be broken, and you are left with some new kind of species. Those are known as intermediates. So all the reaction molecules must undergo collision simultaneously. To form product molecules. Simultaneously. Why simultaneously, Jesslyn, Aisha, Marwa? Because Ibrahim, if they do not collide simultaneously, some of them are left, so they need more than one step to undergo complete reaction. Okay. For example, if you have SN2 reaction, so how SN2 happens? You take CH3Br, okay, OH minus. This OH minus SN2 is single step. So it can react. This must collide in just one step and form a product. Got it? So in between, there is, if you try to click a picture of what is happening in between, you will see this. Okay, you will see this. This is the transition state. There, and which involves bond formation and bond breaking. We have seen that transition state of SN2. Okay, this is the transition state. But in a complex reaction, all of the reactant molecule are not able to react in just one step. Some of the reactant molecules may participate in this next step. Okay, and in the first step you may end up with some reaction species, okay, which have incomplete bonds. Those are known as intermediates, reaction intermediates. Got it? So reaction intermediates, complex reactions, for example, SN1. SN1 is a complex reaction. Okay, it involves, so how it proceeds. Yeah, Ibrahim, can you help me out to figure out SN1? I will write the equation first. This is the final. These are the reactants and products. Got it?
Yes, sir. Yes.
HBS. So how it may be happening if it is SN1? Ibrahim, can you help me out?
So the OH group.
Will it
No,
be able
wait,
to
no.
hit the carbon atom directly? This is a tertiary carbon atom.
No, no. The OH won't directly attack the carbon. Yes,
Yes, because this was having only hydrogens in SN2, smaller alkyl group, so nucleophile was able to hit directly.
yeah. So first the Br will get removed and we'll get carbocation. Yeah.
Exactly. So this is the first step. No, or I will write it. This is the first step. So all of the reactant molecules have not participated in the reaction, as you can see here, right? They have not participated. Clear or not?
Yeah.
And this is because it is multi-step, so there could be some slow or fast step also. This is a slow step leading to the formation of, and these are the intermediates, carbocation intermediate. Then, because all the reactant molecules have not participated in just one step,
So for step two, the
Step two, what
nucleophile,
happened?
like OH, yeah, the OH
Yes.
will attack the
Yeah.
carbon.
Now the carbon is more free. So now the OH will attack. Okay, this is a fast step. And then you remove H plus, which, which gives you product. Got it? Is it clear?
Yes.
So this is a multi-step reaction. In multi-step, you need to know slow step and fast step. Okay. And now we will introduce one more term, that is molecularity. What do you mean by molecularity of a reaction?
So maybe like the total number of molecules that are involved in the reaction, I think.
Yeah, total number of molecules and undergoing collisions simultaneously to form product point. For example, Marwa, Aisha, Jasleen. What is the molecularity in this case? What is the molecularity of SN2 reaction? How many molecules are reacting? Molecularity is how many molecules are undergoing collision simultaneously. In the this step, Marwa, Aisha, Jasleen, tell me what is the molecularity? Molecularity, what is the molecularity? What is the definition? Yeah, what is the molecularity of this, Aisha? Is it one or two?
Two.
Two. Exactly. Bimolecular. Jasleen. Right. So molecularity, number of reactant molecule undergoing collision simultaneously to form product molecule. And this molecularity is two. Bimolecular reaction. Molecularity can be defined for elementary reaction. Got it? complex reaction, there is no meaning for molecularity. Is it clear?
Yes, sir.
Why the term uh, overall molecularity of a complex reaction is meaningless? Why is it so?
Also, because the reactants won't directly give the products, yeah, they'll have to undergo steps, so it won't carry a meaning.
Because they're not reacting together. Okay. Is it clear? They are not hitting simultaneously. That is all. So this I hope is clear to you. Okay. Is it clear or not? So if I ask you what is the molecularity of this reaction, what will you say? What is the molecularity of SN1 overall reaction? Has no meaning. In complex reaction, each step has its own molecularity. Got it? I can talk about the molecularity of step 1 or step 2, but cannot talk about the molecularity of the overall reaction. Is it clear? Okay. Because suppose step 1 has a molecularity 1, step 2 has a molecularity 2. So this I hope is clear to you. Got it? So this I think you are able to understand. So molecularity, the definition you need to know. Overall molecularity can be determined by if you know whether the reaction is elementary or complex reaction. In elementary reaction, the molecularity can be defined for the complete reaction, but in complex reaction, it cannot be defined. Got it? Because complex reaction takes place in multiple steps. Got it? So this I hope is clear to everybody. So rate law can be written directly for the elementary reactions. Single step reactions. Rate law can be directly written. For example, Is it clear to all of you?
Yes, sir.
Aisha, Marwa, Jasleen?
Yes, sir.
What if it is a complex reaction then? Is it clear?
Yes, sir.
So it cannot be determined if it is a complex reaction. So can I write it like this? Is it correct or incorrect? Yeah, tell me. Ibrahim, Marwa, Jasleen, Aisha, can I write it directly? No. Then how to find it? we discussed experimental method to find the rate law. So x and y can be determined experiment. We have seen different methods. Initial rate method we have seen. Okay, and we have seen different methods so that can be employed to do this work. But directly it cannot be written. Got it? Is it clear or not?
Yes. Yes, sir. Yes, sir.
So it may be equal to 2 and 1, but you need to figure it out experimentally. Okay, but here it is directly you can write it without any problem in this. But in that case, you need to check experimentally, and then you need to figure it out whether it is matching or not. It can be different also. Okay. There is one more thing which I need to tell you. Will depend upon whom.
The slowest reaction, I think, yeah?
Yeah,
The one
why?
which takes the most,
Hmm.
that's the rate determinant.
Yeah. Why is it so? Why, Brian, do you think that it is the case?
Because because time of the fast reaction can be, say, it can be negligible. So I think this one should be considered.
Exactly, because that is the longer period. This is the longer period. So overall time will be determined by that. Got it? And this step is known as got it? Is it clear?
Yes, sir.
Mhm.
So what's the full form of RDS? Aisha, Marwa, tell me.
Rate determining step.
Exactly. Okay. So this is the basic idea behind the mechanism. In this case, Clear? But this, in this case, you cannot predict. You need to figure it out experimentally. Okay. So I hope this is clear to all of you. Any doubts on this?
Yes.
Okay. Now let's take some examples of the mechanisms, and let's try to figure out what is the rate law. Okay. I will write the reaction, overall reaction. And I will write the mechanism. This is given to you. Got it? So, Marwa, tell me, is it a complex reaction or a single elementary reaction? Complex or elementary? Am I audible, Marwa? Aisha, tell me, is it a complex or elementary reaction? Jasleen, complex or elementary?
Complex.
Yeah, it is a complex reaction. Correct. And the rate will dependent upon the step 1 or 2.
Step 1.
Yes, because it is the slowest step that is taking more time. So rate is dependent on this. and this complex reaction. So I will write rate on the basis of this. I will not write the rate as by looking at okay, Justine, no problem. So yeah, exactly. So uh, because it is a complex reaction, you can't write it directly, as I told you just now. You need to know this mechanism and this RDS. That, that you can write it at. Is it clear to everyone? Got it?
Yes.
So this is how you need to find the mechanism, and if it is given, you can write the rate law directly. Okay. Let me take one more question. So these are the two steps. So What is the rate law? I will give you options. Yeah, Aisha, correct. And it is because it is matching with the RDS. Got it? Is it clear? So if it is matching with the RDS, then you can write it directly. Okay. Let me take one more example. So this is going to the answer. The answer this is not matching with the RDS. Okay. Similarly, this is also not the answer. This is not the answer. Okay. Let me take one more example. Decomposition of H2O in the presence of I minus catalyst. So this is given to you. Okay. Or indirectly, if the rate law is given, you can cross check which is matching with the RDS, and accordingly you can select the mechanism or the RDS also. So this is H2O2 and I minus. This is first step. This is slow step. And this is the second step, which is the fast step. It is giving these products, I minus and O. So what should be the rate law? Yes, Aisha, Ibrahim, Jasleen, what should be the rate law? Arwa, you know this is the slow step. Got it? So we can write it. Yeah, this is a complex reaction, and the overall mechanism is given to you. It is divided into two steps, as you can see, slow step and fast step. Okay, and you can write the rate law. Is it clear? Is everybody agreeing with the answer? Tell me quickly.
Yes, sir.
Okay, so very simple. But suppose if this is given, then you can back calculate. You must think that this should be the RDS, right? And accordingly, you can try to figure out the products which are being formed. Products are already given. Some this is an intermediate. So this I hope is clear to all of you. Now let's move on to the next topic of this chapter, and that is so generally, what do you feel about it? If you see that the temperature is increasing, we are we are now moving towards the next factor, okay, of which the factor which control the rate of reaction, and that is the effect of temperature. So how it governs and how it affect the rate of the reaction? Will it affect or will it not affect? What do you feel first? Tell me. All of you tell me. Should it affect the temperature? Of course, it should affect, and we see many places like burning of coal, which occurs very quickly if you heat it. Okay, so we have seen a lot of chemical reactions where the temperature play a key role. Okay, and the temperature is actually uh, more higher the temperature, higher will be the rate of the reaction. Okay, we have seen it at many places. Okay, so temperature affect the rate of a chemical reaction. And how it affects? Is it directly proportional, Ibrahim, or inversely proportional?
Must be like inversely proportional, I think.
Inversely proportional. If you increase the temperature, if you heat a reaction,
No,
is
no,
the
no,
rate
wait.
going
It
to
will be
be
directly
more or less?
proportional. Rate has to be directly
Rate
proportional.
has to be. It
Directly
has to be.
proportional.
Yeah, rate should be directly proportional to the temperature. Exactly. So you see it happening many places where you increase the temperature and the rate increases. Is it clear? The reaction becomes faster. And normally, it becomes 2 to 3 times normally. Okay, it can be more, it can be less. I'm giving a very general idea. Is it clear or not? So why actually the rate is increasing with temperature? What is the factor in the rate law which increases with temperature? Tell me. Ibrahim, Destin, Marwa, tell me quickly. Actually, which is the thing which is increasing with the temperature?
That's K. Because
Yeah, this is the K
yeah, K.
which increases. Concentration remains same. Okay.
Yeah, it will remain the same. Won't it evaporate though? Like if it's a
Yeah,
liquid reaction, so
concentration. Yeah, concentration depend upon the total volume. Okay. And if you have kept a, if you have taken a rigid container, the volume will remain same. Mostly the container is rigid. Okay.
okay, so
So basically, the concentration remains same. Actually, the K increases with the temperature. And that is why the rate. Is it clear to everyone? The K increases, the rate also increases. For every 10 degree, the K become twice the rate also becomes 2 to 3 times with every 10-degree rise in temperature. I hope this is clear to all of you. Any doubts in this? This is the basic thing, but why it is happening, that we can understand. And we can also write the relationship which tells us how the K changes with temperature. K depends upon temperature, and how it depends, it is given by Arrhenius equation. This is how the K depends upon temperature. This is K is the rate constant. For a given reaction. A is the pre-exponential factor as it is before the exponent term. A is the pre-exponential factor of the frequency factor. And this is known as Boltzmann factor. Exponential factor, that is also known by the name of Boltzmann factor. What is EA? Ibrahim, can you tell me? Aisha, Jaslin, Marwa, what do you think EA is?
Activation energy.
Activation energy for the given reaction.
Is it activation?
Yes, exactly, activation energy. And what is the unit?
I think it has to be joule.
Yeah, it is joule per mole. I will define it. First, I'm writing what does each term, what is the name of each term, right? And I will give the definition after it. Activation energy of a given reaction. R is the gas constant that all of us know very well. 8.314. This is joule per. Normally it is given in kilojoule per mole, so you can convert it into joule per mole. R is 8.314 joule per Kelvin per mole. Got it? And what is T? Yeah, Ibrahim, Jasleen, Marwaj. This is the temperature in Kelvin. In Kelvin, you need to take. Got it? Is it clear or not?
Yes, sir.
So this is the whole equation which relates the K, the rate constant, with the temperature. Okay, what does this A means? What is the meaning of A? It is a pre-exponential factor. This is quite common name because it is coming before the exponential part. It is a frequency factor because it represents the number of collisions per second. It represents the collision frequency. Okay. And this is the Boltzmann factor, the exponential term, that is e to the power minus A by RT. E is the activation energy. So frequency factor is clear. So how many collisions are taking place? Bimolecular collisions are taking place per second in a given reaction. That depends upon the temperature. That is called frequency factor. And this is the rest of the part is exponential factor, and it has EA in it. EA is the activation energy. How do you define activation energy?
So you can say the energy required to start a reaction.
Energy, extra energy, not the total energy. Okay. Suppose if this is the, I'm drawing the energy profile of a reaction. Suppose if you start with reactants and the reactants are they have certain energy. And this is the progress of reaction as you move forward, how the reaction proceeds, means reaction coordinates. You have reactants, they have certain energy, and as the reaction, but the reactant cannot react, suppose if you have a piece of coal or a petrol or at room temperature, they will not burn. Okay, though you have oxygen also, it need to be ignited, so some extra energy need to be provided so that the reactant can break their bond and this cross this energy barrier. This is the potential energy barrier, which is known as EA or activation energy. This is the potential energy barrier. It need to be, so the reactant molecule must have that extra energy. This much extra energy, then only they can come to the other side of this. So that extra energy need to be given. That is called activation energy. Yeah. So Ibrahim, can you read it out for me?
Activation energy is the extra energy needed to be given to the reactant molecules so that they can cross the potential energy barrier and can successfully form the product.
Yes. So extra energy need to be given. Okay. This is known as activation energy. If I'm here, I want to come this side, I can't just go down. I need to jump with some energy, then only I'm able to successfully cross this barrier. Okay, energy barrier. Same is the case with the reacting molecules also. Okay. So this is the energy of the reactant. This is the energy of the reactant, ER. And if you provide that barrier is EA. That barrier is extra amount which you need to provide. And the energy after getting this activation energy, the total energy becomes this much. Right? This is known as ET, threshold energy. The value of the total energy. Okay, threshold energy. Activation energy. And energy of the reactants. The extra energy when you add, get the threshold energy. Is it clear or no? Got it? So what is threshold energy? Ibrahim, tell me, how will you define it? But whatever that extra energy,
The total energy of the reaction. The total energy of the reaction.
yeah, total energy of the reactant. Okay.
I am
Which,
the total energy of the reactants.
which is equal to the original energy of the reactant and extra energy, the energy barrier EA plus activation energy. When you add it to it, the whatever the total energy becomes, that is known as threshold energy. Got it? So only that extra energy need to be given. Okay. And out of all the collisions, only these too many molecules are able to surpass that energy barrier. Okay, this is the exponential form of the equation. Okay, then you have logarithmic form. This is log to the base E. which cannot be seen from the table. Log table is log to the base 10. So you can convert it to the log to the base 10 by multiplying it by 2.30. Got it? So this is actually the overall equation. Is it clear or not? So this is log to the base 10. So if they give you the pre-exponential factor and the activation energy and temperature, you can put it the values here. No, be careful about the units. Got it? And that's how you are going to get K. Is it clear or not? Any doubts in this? So
No, sir.
this is the equation, but you cannot use to get the value of rate constant, because normally for this you need calculator to calculate this. Okay, for log. So you need to take log. Okay, and if you plot the graph between log and you will have a linear graph, right? Log k and 1 by t. What is the slope? Here, this is a straight line curve. But suppose if you are given with two, the most common questions are given in which you are given with two temperature. At one temperature, the value of K is given, and you are asked to calculate the value of K at another temperature. Okay, so what you will do here is you have K1 at T1, K2 at T2, right? So I will write for T1 and T2 rate constant is K1 and K2. Okay. You don't need to do it. I am doing it for you just one time. You need to remember the final form. The final form will be this one. If you subtract equation 1 from equation 2, okay, I will take activation energy by 2.303 R common. And you have K2 here, so T2 minus T1 by T1. Okay. This is the form which will be useful in all the calculations. Okay. So this you are going to calculate the new value of k if you have the original one. How you are going to calculate the new value of k? Tell me. You will put log k2 by k1. K1 is the original value which you are going to put here. You are going to put the value of activation energy R, new temperature T2 and T1 old temperature T2 minus T1 by T1 T2 in Kelvin. You are going to put all these values and you are going to solve it for K2. Okay, put T1, K1, T1, T2, R, E, A, and get the value of K. Is it clear or not? This T1 and T2 must be in Kelvin. R, as I told you, it is 8.34 joule per Kelvin per mole. But if you look for the energy of EA, it should be in joules. If it is in calories, then you need to take R as 2 calorie per Kelvin. Actually, it is 1.98. So I rounded off to 2 per mole. Is it clear or not? If it is in calories, then you can take the R in calories. If it is in joule, you can take the R in joule. Temperature you are always going to take as in Kelvin only. So write the formula first. The calculation can be difficult because it involves a lot of multiplications and divisions. So I should suggest that you should first write the formula so you don't lose the marks. K2 by K1, T2 minus T1 by T1 T2. So you have K2 in the numerator and on that side you have T2 in the numerator minus T1. Okay, log K2 by K1. Activation energy, it is given in kilojoule per mole. If it is given in kilojoules per mole, normally it is in kilojoules per mole. Convert it to joules per mole by multiplying it by 1000. Do take care of this thing. Is it clear? So be careful about it.